Alright, Bismillahirrahmanirrahim. Assalamualaikum. We're going to go for chapter number 3, which is Introduction to Probability. Before we get introduced by the term of probability, let's go to counting rules, right? So in many problem of statistics, we must list all the alternatives that are possible in a given solution, or at least determine how many different possible are there. Right. To determine this number, there are three methods of counting rule. First is a fundamental of counting rule. Second is permutation rule, and the last one is combination rule. We will look into these three methods under this topic, which is counting rule. So we will learn how to count, right? So there are several theorem that I'm going to introduce in this chapter. Please take note all the formula, all the theorems, right? We will use all the theorems in solving the problem in counting rule and probability, right? So the first theorem is an operation consists of two steps, right? If your operation consists of two steps, which the first can be done in n1 ways and the second can be done in n2 ways, then the whole operation can be done in n1 multiplied with n2. So what does it mean? It means that, let's say you have a choice. Let's say you have shirt to wear, let's say blue color, right? Red, yellow, right? This is shirt. Let's say you have a shoe, right? Let's say you have black shoes, white shoes, and last one is, let's say you have a red shoes, right? So you have a choice in a day to pair your shirt and shoes. Contoh, for example, so let's say you have a choice whether you want to choose either blue shirt and black shoes, blue shirt or white shoes, blue shirt or red shoes, right? So to know how many possible choices that you have, right? For the first occasion, for the first step, you have n1 equal to 3 alternative. For the second step, you have also n2 equal to 3 alternative. So to know how many possible outcome or how many possible way to choose shirt and shoes, so you need to use n1 multiply with n2. So 3 multiply with 3, so you will get 9. So you have 9 choices. So if you use manual calculation, so for blue one, you have 3 alternative, 3 option. For the red one, you also have 3 alternative. And then for the yellow shirt, you also have 3 alternative. So altogether you have 9 alternative. So this is very important theorem. This is a very basic theorem. So you can use this theorem in many applications, such as in deep learning, also using this theorem to determine how many possible outcome, right? So let's look at theorem number 2. Theorem number 2 is an extension of theorem number 1. If theorem number 1 says that you have two occasion, two situation. For theorem number 3, you have, let's say you have many situation. So the situation or the formula same means that if the first step can be done in n1 ways, second step can be done in n2 ways, and based on first and two step, the third step can be done in n3 ways, and so forth. Means that you have many possible choices. Let's say you have pens, pens color yellow, red, blue. So you need to extend by n1 multiply with n2 until nk. So depend, K is number of step, means number of situation, how many step you have. So this is the important formula or basic fundamental of counting. Right, let's look at example number 1. So a quality control inspector wished to select part for his inspection from each of 4 different bins contain of 4, 3, 5 and 4 part respectively. Means that they have first bin you have 4 items to choose, second bin they have 3 items to choose, and third bin they have 5 items, and the fourth bin they have 4 items to choose. So n1 equal to 4, n2 equal to 3, n3 equal to 5, and 4 equal to 4. So to know how many different ways can he choose, the 4 part is 4 multiplied with 3 multiplied with 5 multiplied with 4 should be equal to 240 ways. Very simple question, right? Example. Let's look at example number 32. How many possible outcomes when we roll a pair of dice, one red and one green? So one red and one green doesn't matter. So in a red die we have n1 and red. We also have 6 possible outcomes, and green we also have 6 possible outcomes. So these two together will leads to 36 ways. By using the first theorem, n1 multiplied with n2 equal to 36. Right, let's look at example number 33.3. So example number 3.3, a coin and a die are tossed together. How many different outcomes are there? So a coin and coin. So how many possible outcomes for a coin? So there are 2 possible outcomes, whether head or tail. For a die, so we have 6 possible outcomes. So to know how many combination outcome, right, different outcome are there, so 2 multiplied with 6 equal to 12. So we also can illustrate like this. Let's say we have 2 outcome, right, head or tail, by using a tree diagram. If you got head, so you're going to have 6 possible outcome, whether the die is going to be 1, 2, 3, 4, 5 or 6. So another one, 1, 2, 3, 4, 5 or 6. So altogether equal to 12. Right? This is by using a tree diagram method. But by using theorem number 1 or theorem number 2, it should be should getting the answer very fast compared to illustration or manually calculation, right? So now let's look at example number 3.4. In example number 3.4, it's a bit complicated. So we consider 3-letter word that can be made from the letter WORD. So we have WORD have 4-letter word, right? WORD have 4-letter word. In from the letter WORD, we want to form 3-letter word only, right? So we want to form 3-letter word from the letter WORD. So then you look at the condition here. Condition here says that if no letter is repeated. So how many steps to rephrase this letter? So let's look at the letter word, WORD. So this one we have n equal to 4. So by using theorem number 2, right, theorem number 2, n1 plus multiply with n2 multiply with n3, the first word to be choose, we have 4 options, right? Either WORD, right? The second place, if no letter is repeated, let's say we already choose the word W, right? So we only have left 3 words, right? So we have 3 words. So let's say we already pick O in second step. So the third step, we only left 2 words. So we have 2 words. Two letter, right? So the first step we have 4 option. The second step we have 3 option. The third step we have 2 options. So how many ways to rephrase this? 4 multiplied with 3 multiplied with 2 should be equal to 24 ways to rephrase the word, the letter word, W-O-R-D, right? So yang mana tak buka webcam, tolong switch on your webcam. Alright. So now let's look at example number 3.5. So consider 3-letter word finishing or starting with O. Finishing or starting with O. So in mathematics, if you still remember logic mathematics, if you have the word or, it means that you're going to do a addition. If you have the word and, so you will use multiplication, right? So this is based on the logic, right? So now, dia kata kat sini, consider 3-letter word starting or finishing with O that can be made from the letter W or D. So the condition here is no letter is repeated. So how many ways to rephrase this letter? So let's look at starting with O. Starting with O, we want to create 3-letter word. So W-O-R-D. So let's say we pick O, means the only one O lah in the letter W-O-R-D. And then when we pick O, there are 3 letter left. So the second letter should be, you can only choose 3 out of 3. The third letter, let's say we choose W, so we only have 2 letter left. So starting with O, it should be equal to 1 multiplied with 3 multiplied with 2, it should be equal to 6. Right? Finishing with O. Finishing with O, same as the starting with O. Instead of starting with O, we finish with O, right? So the last step should be always equal to 1, right? The last step should always equal to 1 from the word W-O-R-D. So 1 is already reserved at the finishing step. So we start from the first step. First step, we have 3 options. So we have 3 options. So let's say we already picked W on the first step. What left? How many letters we left on the second step? So we left 2 steps. Right, so this one should always, if you apply theorem number 2, 3 multiplied with 2 multiplied with 1 is equal to 6. So since starting or finishing with O, starting with O is 6 step, 6 alternative. Finishing with O, we also have 6 alternative. So the how many way to rephrase this is 6 plus 6 equal to 12. So I hope you understand how to use theorem number 1 and theorem number 2. Okay. Any questions so far before we move further? Right. So now let's look at the note. So from the previous example, I always all the example are putting the condition repetition are not permitted or no repetition required. Right, kalau tengok semua example belakang ni, no repetition, no letter is repeated. So if you notice the trend, if no letter is repeated, the number is keep on decreasing from left to right. Nampak tak? 4, 3, 2. So let's say example number 3.4 ni, let's say we change the condition, right? Instead of no letter is repeated, so let's say letter can be repeated. Repetition is permitted. So let's say 1, 2, 3. So the first step we have 4 choices. The second step, let's say the first step you already choose W. The second step we can always choose W juga kan. You can also choose W because the repetition is permitted. The second step is 4. The fourth step also 4. So 4 multiplied with 4 multiplied with 4. Right? This is the number of way to rephrase the letter if the the repetition is permitted. Right? So means that kalau you tengok trend ni, if repetition is not permitted, this one, if the repetition is not permitted, the trend is decreasing from left to right. If the repetition is permitted, the number are same from left to right. This is what I'm going to say. I'm trying to say in the note. Right. Let's look at theorem number 3. Theorem number 3 says that the number of permutation, the number of arrangement of n distinct object is n factorial. So n distinct object is n factorial. Means that if we have a distinct object, means that there are no replicate number or replicate letter, right? So to find number of permutation, number of way to rephrase the letter or number of way to find a possible alternative is n factorial. Factorial means that n multiplied with n minus 1 multiplied with n minus 2 until 1. So, and then we need to understand 0 factorial is equal to 1, right? Now let's look at example number 3.6. So how many different ways can 5 starting players of a basketball team is introduced to the public? So now, starting players are human are unique, right? Is distinct. Even you have a twin, exact twin pun, maksudnya dia still unique, right? So this is a 5 unique players. So to know how many ways to introduce the basketball players is 5 factorial, which is equal to 120. Right? 120. This is 5, right? Bukan S. Okay. So very simple example. Let's look at example number 3.7. So number of 6 letter word that can be made from the letter factor. Right? So this is the same concept as in theorem number 1 and theorem number 2. But theorem number 1 and number 2, we can choose how many letter word to form. But in this theorem number 5, right, if we have 6 letter, we will use or rephrase 6 letter juga. Right? We will use all the letters. Right? So, and provided all the letters are unique or distinct. Right? So if you look at factor, the word factor, F-A-C-T-O-R, there are no repeated letter. So since there are no repeated letter, so number of way to rephrase the word letter is 6 factorial. Right, is 720. Right. So if you have my books, I already explained. So in this lecture, I re-explain if you not understand the statement or solution I already provide. Right. So look at example number 3.8. It's the same concept, right? So we have PQR. So how to rephrase PQR? 3 factorial. Because the letter PQR are not repeated. It's a unique letter or distinct letter. So basically it's the same concept. Like if you look at when I extend the formula of factorial, it still go back to theorem number 1 or theorem number 2. Right? 3 multiplied with 2 multiplied with 1 with no replication permitted. right? So example number 3.9, example number 3.10, 3.11 are all the same concept. So you need to read by yourself. Later on, at the end of this topic, we will do extra question. Right. Now let's look at the permutation. Permutation, for a situation where the outcome are different ways in which a group of objects can be ordered or arranged. The permutation is choosing R object without repetition from n different objects such that order is important. So in permutation, we will learn the formula of NPR. Means that for the formula NPR means that when you have a group of object to choose from, let's say number of student, let's say from 1, 2, 3, 4 until 30, right? So and dekat sini dia kata number of outcome are different way in which a group of object can be arranged or ordered, right? So means that dekat sini object dekat sini mesti distinct object. Distinct object, right? Mesti unique object lah, right? So let's say I want to choose a committee, right? Consists of president, vice president, treasurer and secretary. Ada 4. So in this choosing committee that I want to form must be in order. The first person that I want to choose is president. The second one should be vice president. The third one should be treasurer. The fourth one should be secretary. It should be in order. Maksudnya mesti dalam order. From, I nak choose, I nak ambil 4 orang daripada from 30 student. Number of student is equal to 30. So I want to choose R equal to 4. I want to choose 4 person out of 30 person, and with the condition is this the number that I want to choose is can be ordered or arranged, or must be ordered or arranged, right? Maksudnya the first one, the second one, the third one and fourth one, right? So since the object can be arranged or ordered, the permutation is choosing R object without repetition. Without repetition means that in this group of object dekat sini is a distinct object without repetition, right? So now to choose this one, so 30P4. So this is the formula. This is how we use to find a number of ways to choose 4 person to form a committee out of 30 students. So use calculator, click on 30, shift, division. Multiply. Tekan multiply, so you akan keluar P. And tekan 4. So it become 60. So 657,720. Right? Boleh dapat? Do you get it?
Yes, sir.
Right. This is just as an example. So this the theorem I explained in theorem number 4, right? So the arrangement of an object is in a specific order. In a specific order, this is need to be highlighted. Using R object at time is called permutation of an distinct object taking R object at a time. Right, so the proof, you don't need to see the proof, just jump to example number 3.12. Right, so in example number 3.12, in how many ways can a local chapter of American Statistical Association schedule 3 speakers for 3 different meetings if they are all available on any 5 possible dates. So dates is in order, right? So this is day 1, day 2, day 3, and day 4, day 5, right? It should be in order. So we have n equal to 5. So out of 5, we want to choose 3 dates, right? And these 3 dates should be in order, right? So n p 5. So it should be np5 rather. N is equal to 5, p 3, right? It should be equal to how many? 60, right? Okay, very simple. So it can be used. You also can use second theorem to solve the problem. I already explained here. So basically, it's, first and second theorem is very important theorem. It's a fundamental theorem. Right. Let's look at example number 3.13. A musical director can select 2 musical plays, right, to present next year. One will be present in the fall and one will present in spring. Means that it should be in order, fall and spring. And if she has 9 to pick from, how many different possibilities are there? So 9 pick 2, right, should be equal to 72. Right, very simple question. Now let's look at example question number theorem number 5. This is an extension of theorem number 1 and number 2, right? This is another important theorem, right? In theorem number 1, 2, 3, and 4, we are talking about distinct object. We are talking about unique object, right? So if you, let's say you have a repeated object, for example, let's say you have Muhammad, Mohammad. So we have 1, 2, 3 letter of M, 1 and 2 letter of A, right? So we have a repeated object. So contrast to theorem number 1, 2, 3, and 4, we are looking into a distinct object, right? So now in theorem number 5, we are looking into we are looking into a repeated object. So if you have a repeated object, right, let's say the number of permutation of n object in which n1 are one kind, n2 are the second kind, until k kind. So n1 plus n2 until nk is equal to n. So then to find the number of permutation or number of ways to rephrase is n factorial divided by n1 factorial multiply with n2 factorial multiply with n3 factorial until nk factorial. N1 means that how many are repeated. For example, let's look at this example. So the total n here, let me clear. In Muhammad, right? So we have M, NM, we have 3. NA, we have 2. The total N, we have how much? 1, 2, 3, 4, 5, 6, 7, 8. Right? So to rephrase the word Muhammad, so 8 factorial divided by how many repeated object? Right? Basically, 3 factorial for M. O we have 1, right? 1 factorial. H we also have 1 factorial. A we have 2 factorial. M already done. A also done. D we have 1 factorial. And remember 1 factorial is equal to 1. So that's why we no need to write down 1 factorial. Just write down the number that not equal to 1. 3 factorial multiply with 2 factorial. So become how much? So 8 factorial divided by 3 factorial multiply with 2 factorial. So become 3,360. Right. This is how we calculate, rephrase, or find the possible outcome when there are repeated object. Okay. Try to understand example number 3.14. Kita rest for 2 minutes. Alright. Okay. Alright. Let's move on so we can finish it early. So now let's look at example number 3.14. See in how many ways can two painting by Monet, right? Monet have two painting, and we have 3 painting by Renoir and 2 painting by Roger, right? So R1, R2, right? So this is the same object, right? In Monet have 2, Renoir have 3, Roger have 2. So the total n should be equal to 7 factorial. So 2 factorial multiply with 3 factorial multiply with 2 factorial should be equal to 210. So I already mentioned here, right? So it should be very easy. Let's look at example, this one, example 3.15, right? So I don't know why they lari. So how many different permutation can be made by using the letter word books? So books, if you look at books, we have double O. So the total n is equal to 5 factorial divided by 2 factorial should be equal to 60. Right? And Lotto, same as books, we have we have 5 object, 5 factorial divided by, we have 2 O and 2 T's. So 2 factorial should be equal to how much? 30, right? Okay. So instead of doing mathematics, let's change a bit to statistics. Right, statistics. So the number total n is equal to how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 letter. Betul? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to find different number permutation that can be made by the word statistics is n factorial, let's say 10 factorial. 10 factorial divided by, as we have 3 factorial, A only have 1, T kita ada 1, 2, 3, 3 factorial, I we have 2 factorial. I think that's all. Yeah, the repeated object. So this one should be equal to how much? How much?
50,400.
50,400. Yep, correct. 50400. Right, good. So I hope you understand the theorem number 5. Right. Now let's look at the example 3.17, 3.18. I think I'm going to show you 3.18. Right. For 3.17, I think it should be very easy. Now 3.18. So how many possible permutation of the letter word adding? Are the two D's be together, right? So what we want to know, what I want to do is we want to rephrase the word adding, but the two D's should always be together. Maksudnya D-D-A-I-N-G, or it can be at the back, or it can be after A, after I, or after N, after G, right? But as long as two D's together. So now we have the word addings, but the condition is if you want to find the word adding, we want to rephrase the word adding without any constraint, without any condition, right? Means that D can be separated, D can be together. So it should be how much? 1, 2, 3, 4, 5, 6. So 6 factorial divided by 2 factorial, right? It should be equal to 6 factorial divided by 2 factorial is 360. Betul lah? Listen carefully. This question is very famous question, right? So now sekarang ni kita ada word A, D, D, I, and G. So since kita nak dia double D's to be together, right? Let log these two together. Now, when we log these two D's together, so we have 1, 2, 3, 4, 5. So our current N is equal to 5 instead of 6. And let's say kita change the word to macam ni lah, double D lah, letak double D. Dia dalam penjara, okay? So dia duduk dalam kotak. So dia mana-mana pergi pun tak boleh dipisahkan. Sehati sejiwa. Right? Boleh? So now A double D I and G. So if you look at this one, A double D ni bukan, dia tak jadi repeated word dah. Dia jadi satu word, satu letter. Sebab kita dah kurung dia sebagai satu. So means that we have all distinct object. 5 object, all distinct object. Sebab kita dah classify dia sebagai satu. So since we have all distinct object, so this one should be equal to how much? 5 factorial. Right? 5 factorial multiply with, so we need to multiply because, kenapa kita nak multiply? Sebab double D can move. Maksudnya dia boleh duduk depan, dia boleh duduk sebelah A, dia boleh duduk sebelah I, dia boleh move. It can move around. Right? So we need to multiply dengan number of permutation untuk double D. Number of permutation of double D itself double D. Maksudnya we have two letter and these two letter are repeated. So by using theorem number 5, 2 factorial divided by 2 factorial. So we need to put this here. 2 factorial divided by 2 factorial. So become 5 factorial. 5 factorial means 120, right? I think yes. So it's equal to 120. Right. So now the next question is how to find number of permutation when the D is separated. The double D's, the two D's are separated. So we know this is the whole package, right? We have the whole package is 360, which is contain the whole package. So let's say we make it a Gantt chart, Venn diagram. So let's say the circle here represent these together. outside of the circle represent D are not together. And the total for this triangle, for this rectangle is n equal to 360. And this is equal to 120. So the balance should be 360 minus 120 equal to berapa?
240.
240. Okay. Right. So let's move to the next theorem. This theorem, this also same. Theorem number, example number 3.19. Assume you can do it by yourself. Let's look at theorem number 6 and 7. 6 and 7 means that the number of permutation of n different object selected with repetition from a set of n object. So kita tengok dekat example number, theorem number 7. Number of permutation of R different object selected from a repetition of set n different object. Basically, theorem number 6 and number 7, you tak perlu tahu pun tak apa, but it will make your calculation short lah, but is basically came from theorem number 1 and 2. Let's look at this one. Let's say you have a true-false question. True-false question, I have true-false question, let's say I have multiple choice lah. For this question, I have multiple choice. Multiple choice question, I have 4 questions for you, right? 4 question, 1, 2, 3, 4 question, multiple choice. So for first question, you have 4 option. Second question, you also have 4 option. Third question, you have 4 option, the A, B, C, D. And fourth question also you have 4 option, whether A, B, C or D. Right? By using theorem number 2, first question you have 4 option. Second question you also have 4 option. Third question you also have 4 option. Fourth question you also have 4 option. 4 multiply with 4 multiply with 4 multiply with 4. In short, it should be equal to 4 power of 4, which is equal to n power of n. Right? It's the same theorem. It's the same concept lah. For this one, let's say instead of having 4 question, I have 5 question. So I have 4. So 4 multiply with 4 multiply with 4, 4, 4. So we have 5 power of 4. Sorry, terbalik. 4 power of 5. Right? Boleh? This is just a mathematical tweaks lah. So you don't need to remember theorem number 6 and number 7. Right? Make it, if you feel that theorem number 6 and 7 make it your understanding confused, right? So just forget it. Just understand theorem number 1 and number 2 and number 5 and number 4 and number 3. Right? Now let's look at example theorem number 8. Yep. Theorem number 8. Theorem number 8, the number of permutation of n distinct object. So if you notice that from theorem number 1 until theorem number 8, only theorem number 5 we are talking about repeated object, right? Lain-lain semua all distinct object, right? So theorem number 8, the number of permutation of n distinct object arranged in a circle is n minus 1 factorial. So let's say in theorem number 8, it doesn't, we does not care where the first object is placed. So let's say if you want to arrange for dinner table, kan? Let's say you have 1, 2, 3, 4, 5, 6, 7, 8. 8 person in a table. So you want to arrange siapa dulu nak duduk mana. So how many possible outcome or possible ways to arrange? So let's say we have 8 minus 1 factorial lah. So maksudnya 7 multiply with 6 multiply with 5, 4, 3, 2 and 1. Right? Okay, this is for a circle permutation lah. Now let's look at combination. This is the last theorem, I believe. Right, combination. After this, we will look into a question, right? Right. Now, combination are same as theorem number 4. Theorem number 4 is about permutation, right? If you still remember. Theorem number 4 or number 3, I think. Number 4 is about permutation. Permutation is when we want to select R distinct object from N distinct object when R object should be in order, right? When R should be in order, then we use permutation. When R doesn't care, tak perlu in order, right? Order is not permitted. Order or rank is not permitted. You use combination. The same concept. Kalau kita ada R itu mesti dalam bentuk order, guna permutation. Kalau R tak kisah, tak perlu in order, use combination. This theorem number 9. Theorem number 9 is same concept as permutation, right? So we want to take R object from N distinct object, right? And order is not an option. So now let's look at example number 3.25. In how many ways can 6 toes of coin yield to 2 head and 4 tails? So dia kata kat sini, in this example, there are a total of 6 toes of coin where we want to obtain 2 head and 4 tails. And where this question can be translated into how many ways to obtain 2 head from 6 toes of coin. And of course, automatically, kalau kita dapat 2 head, yang lain-lain tu mesti tail lah. Sebab dia ada 2 outcome saja. In this question, we doesn't care about the ordering. So 6 choose 2 should be equal to 15. Right? Use your calculator to calculate 6 choose 2. Now let's look at example number 3.26. Right? So there are 6 people to be chosen from. 6 people to be chosen from 5 Malaysian, 4 Indonesians, and 3 Singaporeans. So now the total here is we have 5 Malaysian, 4 Indonesian, and 3 Singaporean. So it should be equal, the total is 12. Is it 12? 9 plus 3 is equal to 12. Right? So now, question number 1. Find the number of ways to choose 2 people from each countries. So we have Malaysian, Indonesian, Singapore. Right? So we want to choose 2 people each country. Right? So how to choose 2 people out of 5 people in Malaysian? So how to choose 2 people out of 5 is 5 choose 2 for Malaysian. And multiply. We want to choose 2 people out of Indonesian. 4 Indonesian. 4 choose 2. Kenapa kita guna combination? Because we don't care about the ordering. Right? And the last one, we want to choose 2 people out of 3. Out of 3 apa ni? Out of 3 is Singaporean. Right? So, what is the answer? 5 choose 2 is equal to is equal to 10. Multiply with 4 choose 2 is equal to 6. Multiply with 3 choose 2 is equal to 3. Right? So 30 multiplied with 6. 30 multiplied with 6 equal to 180. So there are 180 ways to choose 2 people out of Malaysian, 2 people, 2 Indonesian, and 2 Singaporean. Right? And B, find the number of ways to choose at least 3 Malaysian. So 3 Malaysian. Okay. Kita nak choose berapa sebenarnya semua ni? Total berapa? Kita nak choose 6 people out of 12. Kita nak ambil 6 orang daripada 12. Betul? Soalan dia kata, we want to choose 6 people out of 4 Malaysian, 5 Malaysian, 4 Indonesian, and 3 Indonesian. Right? So, how to choose at least 3 Malaysian? So, either 3 Malaysian, 3 others. Or 4 Malaysian, 2 others. Or 5 Malaysian, 1 others. Or 6 Malaysian. No, we only have 5, right? So now we're going to translate this word to mathematical numbers, right? So 3 Malaysian, 2 others. 3 Malaysian, 5 choose 3, multiply with 2 others. So 2 others. 2 tu ni maksudnya 4 dan 3. Singapura dengan Indonesia. So we have 7. Allah, tak terang lah. What color to choose? Pink color. Always pink. 7 choose 3. Plus. And then 5 choose 4. Multiply with 7 choose 2. Plus. 5 choose 5 multiply with 7 choose 1. Then you calculate you solve the problem, dapat the result lah. Okay? It's a simple, right? So nanti you baca kat bawah, tak faham baca kat bawah. So should be equal to berapa ni? 462, right? So now, find the number of ways to choose at least 1 Malaysian. At least 1 Malaysian is quite complicated. So instead of doing this, starting from 3, we start from 1. Choose 1, 7 choose 5. 2 Malaysian, 7 choose 2, and plus everything lah. Or we can use the smartest way, right? Dekat sini dia kata, to select to find the number of ways to select at least 1 Malaysian, we can do some manipulation instead of calculate it naively. Calculate it naively means kita calculate daripada 1, 2, 3, 4, 5, 6. 45 lah. 1 by 1. Susah. So number of ways to choose 6 people without any restriction. So we have 924. Maksudnya kita nak choose 12, 6 daripada 12. 12 ni mana dapat? Combination of Malaysian, Indonesia and Singapore. So we have the total of 924. Right? So number of ways to choose non-Malaysian. Tak ada Malaysia langsung. Tak ada Malaysia langsung apa? Maksudnya 5 choose 0 multiply with 7 choose 6 is equal to 7. Right? So, balik konsep kepada konsep yang saya ajar tadi, Venn diagram. right? Venn diagram. This is all possible outcome, which is 9 to 4. And the middle here is no Malaysia is equal to 7. Other than that, at least one Malaysia should be there. At least one Malaysia should be there. So 9 to 4 minus 7 equal to 917. Okay? Boleh eh? Right. For example, number 3.27, I think you can look by yourself. Let's look at past year question. Past year question. So now, a test paper of a subject has two parts, A and B. So each consists of 10 and 5 questions, respectively. Means that part A, NA equal to 10 and B equal to 5. If a student needs to answer 7 questions from part A and 4 questions from part B, in how many ways can he do that? Maksudnya, from part A, you need to choose 7, and part B, we need to choose 4. Right? Choose 4. We don't care the order. Right? So now, we have two parts. First part, 10 choose 7. Multiply. 5 choose 4. Then you will get the answer lah. Very simple. Only 2 marks. Right. All letter the word environment. Environment will be arranged in form to form a different words. So how many letter can be arranged? So if you look at this word environment, E, we have 2 letter, repeated object. N, kita ada 1, 2. Right? Lagi ada object yang repeated tak? I not repeated, R is not repeated, O so not.
N bukan 3.
N we have 3, yes. N we have 3, M so not. So the total letter dalam word environment ada berapa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divide by 2 factorial multiply with 3 factorial. So this one should be berapa? 11 factorial divide by 2 factorial multiply with 3 factorial is 300,000 332. Sorry, this is quite big. 3 millions. Is it? You got the same? Yeah, you got the same answer. 3326400. To arrange the word environment, we have 3,326,400 ways to arrange word environment without any condition. And number 2 is calculate the probability that the word will have arrangement of vowel that are always next to be each other. So now let forget about the word probability here. We want to arrange the word environment, and we want to make sure the word the vowel are always together. The vowel apa? Apa vowel? Apa letter vowel?
E-I-O-U.
Yes. Right. E, N, Y, Ronman. So total here N equal to 11. So E, lagi kita ada I, O 1, 2, 3, 4. 4, right? Okay, and lain-lain letak tepi Ni letak satu rumah. Letak dalam satu rumah. The next one, tak payah rumah lah. Ini pelarian. Letak dalam rumah. Okay. N, V, R, N, M, N, T. Okay. Cukup. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So now, since dia dalam satu rumah, right? Bagi dia duduk dalam rumah, right? Kita ikat dia together, right? So, this is 1, 2, 3, 4, 5, 6, 7, 8. So now we have n equal to 8. And if you look at the letter n dekat belakang ni, dekat consonant ni, we have n and 3 n, right? So 8 factorial divided by 3 factorial. And then we need to multiply orang-orang yang dalam rumah ni lah. A letter in this house, the vowel letter E-E-I-O means 4 factorial divided by 2 factorial. Right? So you will get the answer lah. Okay? Boleh ke boleh?
Boleh.
Boleh.
Okay. Now let's look at the next question. The English alphabet has 5 vowel and 21 consonants. 5 vowel and 21 consonants. What is the maximum number of words can be formed from the alphabet with 2 different vowel and 2 different consonants? So, apa yang dia nak ni sebenarnya? So, dia ada 21 consonant, 21 consonant and 5 vowel. So, apa yang dia nak buat? Dia nak buat 2 perkataan. Dua letter kan? 2 different vowel. Sorry, bukan. Maksudnya ada 4 lah. 1, 2, 3, 4. Right? The first one, vowel is different object. A, E, I, O, U. Right? So we have 5, choose 2. Multiply with
21, choose 2.
21, choose 2. Right? So how much this one? Berapa?
2,100.
Okay. 2,100. Right? So as I said before, dia ada 2 tempat. Satu vowel, satu consonant. Remember? Right? Dalam ni dia ada 2. Dalam ni dia ada 2. Right? Setiap ni let's say kita assume kita nak buka pemikiran sikit. V vowel, let's say kita ada A and E. Let's say consonant we have N and T. A and E dia boleh berubah kedudukan, right? Dia boleh berubah kedudukan, right? So how many possible outcome there? 4 factorial, right? We have 4 letter, 4 factorial. Right? Perubahan outcome tu dia boleh berubah. Mana-mana suka hati dia lah. Dia nak duduk mana kan. So now, it should become 5 choose 2. Multiply with 21, choose 2. And multiply with, this is the first part, multiply with 4 factorial. Okay. So B should be very simple. The letter word ALT, R, UISM. Each written on card and the card are then shuffled and placed in line. So how many way can the card be arranged? So the word here are all distinct, right? Distinct kan? Kalau distinct kalau dah buat apa? 1, 2, 3, 4, 5, 6, 7, 8. So distinct so means that 8 factorial lah. So 3 letters are chosen at random. I calculate the probability that at most 2 letters are consonant. So now let hold sekejap the probability, right? This is your apa nama subject kan. Hold sekejap probability ni. Kita nak tengok at most 2 letters are chosen are consonant. Right. So consonant ALT semak lah sini, nampak macam semak sekejap. I kena padam sikit. Alright. So kita nak buat ni So ALTRUISM. So consonant, how many consonant we have? We have A, U, I for vowel and L, T, R, S, M for consonant. So consonant we have 5. So we want to know how many letter to be how many ways to choose at most 2 letter of consonant. Right. So 5 choose but before dia kata kat sini 3 letters are chosen at random. Maksudnya dia nak choose 3 kan. Let's say at most paling banyak berapa? 2 letters. Paling banyak 2 letters kan consonant. Maksudnya sama ada 1 consonant, 2 consonant ataupun 3 consonant. Paling banyak 3. At most tengok the word at most. This is the word that you need to know. At most, at least, lagi apa, and, or dalam mathematical words, right? So this one should be 5 choose 2 multiply with, so let's say 5 choose 1 dulu daripada mula. 5 choose 1 at most, paling banyak 3, 1 okay. 3 choose 2. Right, kita nak form 3 letter word. Right? Betul? And then at most, or it can be nanti I think you confused. Let me terangkan sebelum step yang I buat ni. Sebelum step yang I buat ni, at most ni maksudnya apa? 1 consonant, 2 vowel. Ataupun 2 consonant, 1 vowel. Ataupun 3 consonant, 0 vowel. Ini yang dia nak. Right? So daripada sini kita translate lah into a statistical form. And then 1 vowel consonant, 5 choose 1 multiply with 3 choose 2 plus 5 choose 2 multiply with 3 choose 1 plus 5 choose 3 multiply with 3 choose 0. So letak bracket bagi tak nampak keliru kan. This is the way. Right, and you calculate the answer lah. It should be berapa? 45, 46. Okay? Boleh ke boleh? Boleh ke boleh?
Boleh.
Alright, good.
Boleh.
Good.
Sir,
Yeah.
if it's at most, doesn't it mean that the maximum is 2 for consonant?
Oh yeah, 2. I thought 3, sorry. Maksudnya 2 lah. 2 apa nama? 2 letter consonant. Yes, correct. Right. Ini semua dalam tengah hari ni jadi macam ni lah. Right. Okay. Kita ulang balik. So at most 2 kan? 2. Alright, good. Nasib baik. You pay attention. Very good student. So at most 2. Okay. Paling banyak 2. Dia mungkin, okay, I ulang balik. Paling banyak 2. 5 choose. Okay, macam ni lah. Bagi faham. Kita buat kerja mesti bagi faham. Sama ada kosong consonants. Dia 3 kan? 3 vowel. Plus 1 consonant, 2 vowel. Plus 2 consonant, 1 vowel. Paling banyak 2 kan? Okay? Alright, good. So then we translate it to mathematical form. So 5 choose 0 multiply with 3 choose 3 plus 5 choose 1 multiply with 3 choose 2 plus 5 choose 2 multiply with 3 choose 1. Is it correct? Yes. So this is, letak bracket dulu, jangan lupa. Okay. Kira dia dapat answer lah. Right? Boleh?
Boleh, sir.
Okay. Let's look at the last question before we end our session. Before we end, after this, I have a very quick self-test on this topic. Right? Or you want to do tomorrow? Bila you nak buat? Quick test lah. Very simple test untuk check balik your understanding on this topic. I prepare a quizzes punya platform. Ada 25 soalan. 25 soalan, multiple choice. So how many possible outcome are there? I have 25 questions for you. All through multiple choice, 1, 2, A, B, C, D. So how many possible outcome are there?
12,650.
12,650. So means that 4 power of 25. Sebenarnya bukan 12,000 lah, it's a bigger number. Right? It's a bigger number. So you have your multiple alternative to choose. Right? So you tengok dulu this topic. Nanti I akan bagi lepas ni, I akan bagi you jawab lah. So assume that the identification number of all employees in an organization is formed by 2 letters from a selected alphabet A, B, C, D, E, followed by 5 digit from 1, 2, 3, 4, 5, 6, 7, 8, 9. How many employee identification number can be designed if no repetition alphabet number are allowed? So maksudnya dia nak design, this is theorem number 1 and 2. 1, 2 is for alphabet, and 1, 2, 3, 4, 5 is for numbers, digit. For alphabet, we have no repetition is allowed. So 1, 2, 3, 4, 5, 5. The first one have 5. The second one we have 4. And this one, the first one we have 9, 8, 7, 6, and 5. So you need to multiply lah, using a theorem number 2. Alright. Ataupun the second way you can do by using combination method. So we have 5 choose 2 for alphabet. The second one is 9 choose 5 for digits. Right? And this is the easiest way to understand lah, to understand the concept. So let's look at number 2. So no repetition of alphabet. This is the condition. No repetition of alphabet. Numbers are loud. So in addition, the first alphabet must be A and the last number should be 9. So we have 1, 2. This is for alphabet. 1, 2, 3, 4, 5. Right? So the first number should be A, 1. The last number should be 9, 1. And this is start for 4. Right? Sebab kita ada 5 kan? 1, 2, 3, 4, 5. A, B, C, D, E. Ada 5. So A sudah ada. 4 lagi pilihan yang seterusnya. So this one, we start with 8, 7, 6, 5. So 1 multiply with 4. 8 multiply with 7, 6, 5, and 1. So this is the answer. Okay. I think that's all for counting method. For the next lecture, we will look into introduction to probability. But before we go for probability, I require you to understand or revise some knowledge on set theory. Right, so you need to understand what is union, what is intersect, what is a null set, what is complement set, and so on. And what is set is actually, right? So I think that's all. Thank you very much. Assalamualaikum. But